Tachycardia is defined as a heart rate of 100 beats or more per minute. When faced with a tachycardia on the ECG, identification of the anatomical location and nature of the focus of depolarizing current generating the arrhythmia has a critical bearing on treatment. Initially, we will concentrate on the identification of the anatomical location of the abnormal depolarizing focus. An understanding of the mechanism generating different tachycardias will come with analysis of the individual types. Tachyarrhythmias may be divided into two major groups depending on whether their focus of origin is situated above or below the bifurcation of the bundle of His. A tachycardia arising from an abnormal focus in the ventricular muscle mass or in the conducting system below the bifurcation of the bundle of His is termed a ventricular tachycardia. For the reasons outlined in the video on ectopic beats, tachyarrhythmias arising from a focus in this region are associated with broad QRS complexes. Tachycardia arising from a focus in or anywhere above the bundle of His is called a supraventricular tachycardia. In this case, as the depolarization wave generated must enter the ventricles via the AV node and therefore the ventricular conducting system, a tachyarrhythmia arising from anywhere in this region is usually associated with QRS complexes of normal duration, a so-called narrow complex tachycardia. There are exceptions to this simple division, however. For example, it is possible for a focus in the supraventricular region to generate a broad complex tachycardia when conduction between the atria and ventricles, or within the ventricles themselves, is abnormal. Distinguishing this possibility from ventricular tachycardia is an important skill, but this must wait until section 5. We will deal with tachycardias arising in the supraventricular region first. Supraventricular tachycardias may arise from the sinoatrial node or an ectopic focus in the main mass of the atria. In addition, the area encompassing the AV node, bundle of His, and immediately surrounding atrial tissue is a highly arrhythmogenic area of the heart. This area is referred to as the junctional region, and arrhythmias arising from a focus within this region are termed junctional. We will now show you how to distinguish between narrow complex tachycardias arising from each of these three supraventricular zones. This ECG is taken from a previously healthy 23-year-old lady who presents with a pyrexia of 40 degrees Celsius secondary to pyelonephritis. The heart rhythm is regular and there are 12 small squares between R waves, so the heart rate is 125 beats per minute, a tachycardia. The QRS complexes are of normal duration, less than 3 small squares in width, indicating that the depolarization wave is entering the ventricular conducting system. Therefore, we can conclude that the tachycardia has originated from a focus located above the bifurcation of the bundle of His. We note that P waves are present, and we can identify the site of origin of the tachycardia within the supraventricular region by analysis of the P wave axis and PR interval. In fact, the P wave axis is normal. We find upright P waves in both the inferior leads 2, 3 and AVF and the left-sided leads, leads 1 and V5 and V6. This indicates that the bulk of atrial depolarization is proceeding downwards and to the left. Also, the PR interval is within the normal range. This is at least consistent with a normal distance travelled by the atrial depolarization wave from its origin to the AV node, and preservation of physiological delay within the node. Based on this analysis, we can be reasonably confident that this is a sinus tachycardia, a tachycardia originating in a rapidly discharging SA node. Furthermore, the patient from whom this ECG was taken had a pyrexia of 40 degrees Celsius, so sinus tachycardia would be expected in the clinical context. Although a very simple case, our approach to this ECG highlights some of the principles we will use in the analysis of tachyarrhythmias. We used the width of the QRS complex to determine if the tachycardia is supraventricular or ventricular in origin. As it is a narrow complex tachycardia, we concluded that it originates from a focus above the bifurcation of the bundle of His. We then used the presence, axis and timing of the P wave relative to the QRS complex to determine the most likely site of the depolarizing focus within the supraventricular region, in this case the SA node. The clinical context is also important in reassuring us that our ECG diagnosis is correct, as sinus tachycardia would be expected in this scenario. When a supraventricular tachycardia arises from a focus within the junctional region, depolarization will proceed upwards into the atria, and ventricular activation will travel as normal downwards into the conducting system. As atrial depolarization spreads superiorly, the P waves in the inferior leads are negative. In addition, this altered P wave axis is accompanied by an abnormally short PR interval, as the discharge has little, if any, distance to traverse before reaching the AV node, and may actually bypass the normal physiological delay within the node. In fact, depending on the site of origin of the discharge within the junctional region, in some cases of junctional tachycardia, atrial depolarization may be coincident with ventricular depolarization. In such cases, the P wave is not visible as a separate entity on the ECG readout, being buried in the QRS complex. In this scenario, we see a regular, narrow complex tachycardia with no obvious P wave activity. It is even possible for atrial depolarization to follow ventricular depolarization in a junctional rhythm, with the P wave occurring after the QRS complex. So, a tachycardia arising from a focus in the junctional region is regular, narrow complex, and is characterized by a shift in the P wave axis such that the P waves are negative in the inferior leads. The PR interval is shortened. The degree of shortening varies to the extent that the P wave may precede the QRS complex, but with a PR interval less than the lower limit of normal. Alternatively, the P waves may be coincident with the QRS complexes and consequently unidentifiable on the ECG readout. In some cases, the P wave may follow the QRS complexes. Looking at this ECG, we identify a narrow complex tachycardia with a rate of 115 beats per minute. Negative P waves in the inferior leads indicate that the P wave axis is travelling superiorly, away from these leads. This, combined with an abnormally short PR interval, places the source of the depolarizing discharge in the junctional region. This is a junctional tachycardia. Tachycardia arising from a discrete focus in the main mass of the atria, outside the sinus node and junctional region, is termed ectopic atrial tachycardia. The patient from whom this ECG was taken has clearly developed a narrow complex tachycardia. If we focused on the rhythm strip alone, with upright P waves and a normal PR interval, we might reasonably suspect a sinus origin for the tachycardia, but this would be incorrect. Looking at the full 12-lead ECG, we note that the P waves are indeed positive in the inferior leads, indicating that the bulk of atrial depolarization is moving downwards from its origin. However, on closer inspection, we note that the P waves are negative in lead 1 and V5 and V6. This indicates that atrial depolarization is predominantly moving from left to right, and therefore does not originate in the sinoatrial node. This is in fact an ectopic atrial tachycardia, originating from the focus indicated. Analysis of this ECG illustrates a number of principles. Firstly, in general, if P waves are negative in any of leads 1, 2 or 3, or V5 and V6, the origin of atrial depolarization is ectopic, that is, it lies outside the sinus node. Secondly, as a general point, if the patient clinical condition allows it, a full 12-lead ECG should always be obtained when trying to diagnose an arrhythmia. We will discuss ectopic atrial tachycardia again in the quiz section. For now, this slide summarizes the main features of tachyarrhythmias arising from a focus in each of the 3 supraventricular zones.